Hola? Perfecto. I am really excited to be able to speak to you today. It's been wonderful. So many good Argentinian friends over the last few days. I've had some fascinating conversations and some amazing asado also. Muchas gracias, Ariel. Let's thank Juan and Ariel and all of the organizers for putting together such an amazing conference. So yesterday, Daniel and Audrey were saying you shouldn't be shy to upload new packages to PyPI. And I agree. Or maybe I just have no self-control. Because I maintain something like, I think 18, I counted yesterday, 18 packages on PyPI. And a lot of those are libraries. And so I've had a lot of opportunity to think about what constitutes good API design. I'd like to share with you today what I've noticed. Now, I'm giving this talk in English today because your English is a lot better than my Espanol. But this is just the first of many choices about language that we're going to make over the next hour. I love language, but I would not consider myself a poet. However, poets and programmers have a lot in common. We both deal with very precisely formatted language. We both make up new terms. In fact, every time you make a new variable and give it a name, or coin a new function, you are inventing a new piece of language. Now, it's this invention of language, along with all the mental processes involved behind it, that are key to writing excellent APIs. Now, it's vital that we create our new language with care, because the language that you use influences the thoughts that you can think, or the thoughts that anyone can think if they're using that language. For example, who's ever had someone tell them, go learn Lisp, go learn Haskell. It'll change the way you think about programming. Yes. There is some merit to that. In fact, there used to be a psychological, I'll stop short of theory, but an hypothesis that said the language that you use determines and limits the thoughts that you can think. And this was called the strong Sapir-Whorf hypothesis. Now, there were some supports in its favor, some anecdotes. For example, there was a Mexican boy named Ildefonso who was born deaf into a poor family, and they didn't have the resources that he needed in order to learn lip reading or sign language. And so he grew to 27 years old without knowing there was a thing called language. He was a languageless person. As a result, he lacked a lot of power. He could not recall quantities beyond 10 for obvious reasons. Maybe if he took his shoes off, he could get to 20. But later, when he did learn language, he was able to recall those quantities just fine. He was given tools, these abstractions, these categories and names for things that let him hold on to ideas better. Now, the strong Sapir-Whorf hypothesis can be disproved by counterexample. For example, hopefully you're understanding me now. Satisfying translations are possible. Wittgenstein, a German philosopher, writes very intricate prose, very intricate arguments, and yet they can be rendered satisfactorily in Spanish, English, whatever, and they still make sense. Or at least as much sense as Wittgenstein ever makes. But there's still a flavor to each language. Who hasn't accused a colleague, now a lot of us are Python programmers in the room, who hasn't accused a colleague of, oh, you're writing Java in Python, stop that, that's terrible, yes. Or you work with a functional programming person and they're like, oh, stop writing Python in standard ML or in Haskell or whatever. You should be using map and fold. Because, functional languages lend themselves to map and fold. They draw you that way. They influence you. Python makes you use hash tables for everything. You can make a tree if you want, but they'll be made out of hash tables. JavaScript, everything is a closure. So this is the weak form of the Sapir-Whorf hypothesis. This is the one that I think actually holds up. The language you use influences the thoughts that you can think. And the bounds of this influence have been drawn out experimentally. Now, you can help me with this. there are not a lot of English words for colors between red and orange. Now, Espanol has rojo and naranja. Now, are there other words in between, such that if I showed you a swatch, you would probably come up with the same word as your neighbor? Not so much? Yeah, it's a common poorness of our languages. What happens is if you show people in an experiment all these swatches between red and orange, they can certainly distinguish them visually. Obviously, you can tell the difference. But then if you distract them with a card game and bring them back 10 minutes later, they will not be able to recall or remember which swatches they had seen before. They didn't have a symbol, an ability to do recall if they didn't have a name. So it seems like having a symbol, having a name for something makes it mentally lighter weight. When you draw a category like red over a bunch of details like 630 to 670 nanometers in wavelength, you get a mental abstraction, and you can kick all those details, those nanometer measurements, out of your head, leaving room for building higher level constructs, like sentences with the word red. So abstracting out symbols, I would hold, is the root of all human language. But it's also the root of all software engineering. The point of software engineering, I would say, the thing that distinguishes it from just hacking around with spaghetti code, is making software algorithms intellectually intelligible by finding good abstractions. So let's talk about APIs. In creating an API, you make up your own symbols and their meanings, functions, classes, variables, and so on. With the names and the semantics that you choose, you shape all the future thought about that system. Have you ever started using a system and you just can't understand the abstractions? And what did you mean by thing? You know, someone calls a variable foo or a class thing. It doesn't help. You have no idea what's going on. You have to reverse engineer everything, keeping the details in your mind. And you have a limited amount of mind. I have a very small working memory. That's why I have to choose good names for things so that I can work at a high level of abstraction. Ildefonso could not get above 10 until he had the symbols for it. So when you make a good API, you provide other people, or your older self, after all, we're all a different person 6 months after we've looked away from the code, you provide them those numbers after 10, making things mentally lighter weight so that you can think thoughts that you couldn't before. Let's take a look at some code. So this is URL lib2. Isn't this nice? It's a library in the standard lib. You're familiar with it. It has a tendency to be a bit verbose and hard to do things that today are common, like HTTP requests. Though, of course, it has a larger scope than just HTTP. But in today's webby port 80 world, requests, a third-party library, has come to dominate Python web programming. And that's because it uses this de facto standard category called the HTTP request. It exposes things at this higher level of abstraction. In fact, the brilliant thing here is it exposes a level of abstraction, a symbol that people already are familiar with. So one easy win when designing an API is ask yourself, are people already having a symbol for this piece of work? If so, just make that symbol work. Just breathe life into it. Now, it's silly to try to turn good design into a series of steps or a mechanical process you can follow. So let's do it anyway. I'm going to give you 7 rules of thumb that you can use as a checklist. Now, you're not going to get good design for free out of here, but this will certainly help you avoid a lot of wrong turns and keep you from falling off cliffs. The first rule of thumb today is something not to do. And I usually think of this in terms of libraries, but it applies to a lesser extent to all APIs. Don't be an architecture astronaut. The first step in designing a new library for me is to resist designing a new library. It's all well and good to seek to do good design in the abstract, right? But design is basically just imagination. And imagination is nothing more than hypothesizing. And we all know what happens with hypotheses if they aren't continually brought back down to earth and tested and banged against reality. you end up with something like alchemy rather than chemistry. Now, alchemy can be very impressive to look at. I don't know what's wrong with this guy over here. But it can be academically interesting. It can be have lots of flashes of color and such. But really, when it comes down to it, it's merely a self-consistent system of nonsense. You can't actually get any lead out of this gold. Or gold out, you can't do, that'd be cool too. But lead, what they wanted, gold out of this lead. That's it. So let's bring our efforts back down into the realm of science and keep in mind that the best libraries are extracted rather than invented. And what this means is that you should have an application or 2 or 3 or however many you can that already does the task provided by your library. And then take those common bits, those common implementations, and factor them up, pull them up into the library, and you'll be taking into account a wider range of applications. Be more likely to be reusable later. For example, I wrote this plugin called Nose Progressive. It's for the popular test runner called Nose, and its purpose is to display a little progress bar and display tracebacks as you're running the tests, and format them so that they're easier to follow visually. Purple function names, for example, on the right. Now, it makes a lot of use of terminal escape codes for things like bolding, coloring, and positioning, and the code looked something like this. Now, there's a lot of terminal setup and bookkeeping all intertwined with the code that actually keeps track of tests. So this is really hard to read. Don't blame yourself. This is bad. And there are raw terminal capability names from 500 years ago, like SGR0 and RC, that I had to keep on looking up as I was writing this. Every time I'd have to do some formatting, I'd think, geez, I wish there was a decent abstraction or at least some different naming around here so I wouldn't have to look at this and remember it. And it's at this point, this is the feeling you're waiting for, when you have a real working program with a library struggling to get out, that it's okay to start designing a new library. So, it was time to extract this terminal handling, which eventually became my library blessings. Curses, blessings. Let's use that as an example. So, what was my thought process? Well, the first thing is to dump everything out onto the table. What sorts of things ought the library to do? Well, we need to print some formatted text, obviously. And then, in the case of Nose Progressive, I found that I needed to move down to the bottom of the screen, print some text, and then snap back to where I began. So what tools do we have on our workbench? Here are our tasks. What are our tools? Well, we have all the stuff that's already in the language. We have functions, arguments, positional ones, keyword arguments. We have decorators, context managers. Those are a favorite. And classes. And then, of course, we have common patterns as well. Now, these can be things that have special support built into the language, or they can be the sorts of things that arise from a community of practice around a language. In the case of Python, we have protocols like sequences and iterators and mappings, dictionaries and such. Now we have everything out on the table, and we shake the table up and try to find good pairings between these items. What guides you in this? Well, consistency, our second principle. We are fortunate to have the entire cultural and technical weight of the language proper, as well as the accumulated habits of the programming community behind us. So we are not alone when we try to be consistent. We have things to be consistent with. When we're designing websites, which we do quite a bit, at least I do at Mozilla, we think of it this way. People spend 90% of their time on other people's websites. So go ahead, put your logo in the upper left. Make clicking on it go to the home page. Put the login link in the upper right. Make your links blue, and so on. Don't violate people's expectations. When writing an API, realize that users will spend 90% of their time calling other people's APIs. So, if you need to, you can be weird and clever. But if you can manage to stick with conventions, you'll get a lot of bonuses. First, you will convey respect for your users. You're not some outsider porting a Java library who's going to camel case everything and make everyone instantiate 6 objects to get anywhere. 2, you are going to get learning speed and retention. If your library is the same as everything else, there's nothing new to learn and less to remember. One of the brilliant things about the early Macintosh project was their explicit written human interface guidelines. Every program had the same commands: open, close, quit, copy, paste. They were in the same menus and had the same keyboard shortcuts as well. So in a very real sense, when you invested in learning one program, you had learned them all. Now, API design can reuse most of those principles from user interface design. For example, the principle of least astonishment, least surprise. Now, what that means is do your best not to surprise the user. Surprise is fun in games, but not so much in APIs. So if you implement, let's say we have some kind of, key value library that sits on top of a Redis store. We should call our method something like get, and let the arguments be key, and then default. We should not call it fetch and reverse those arguments, because there's no precedent for that in Python, and there's no benefit from doing it differently. This leads us to a third benefit of being consistent, which of course is polymorphism. Pretend this is our Redis thing. Well, if we're writing a test for something, a unit test, or maybe we're just deploying a very small blog, we could just use a Python dictionary, substitute it right in for this, and everything will work just the same. So coming back to our terminal formatting example, how can we pair up these tasks with existing language features and conventions? Well, I like to get as many alternatives out on the workbench as possible, and I call these my sketches. Now, there are really only 2 choices I could come up with for printing at a location. Both are okay, but this first one is just a function call. This second one, though, that uses a context manager, this has some advantages. This has some additional power, even though it's longer. It gives us the flexibility to put multiple statements inside, loops, even calls out to other functions. And the first, which is shorter, can be written in terms of the second very straightforwardly. So we could even add that as a convenience method, and we'd be fine. So we choose the second one as the better core functionality for the library. Now, for text formatting, I came up with a lot more alternatives. We've pretty much got everything possible in here. We have some square brackets. We've got some attributes. We've got, let's see, I didn't use any, no keyword arguments, but I've got positional arguments. Most of them separate printing from formatting, but the first one combines them together. I have a couple of favorites amidst all this noise. This is the favorite. It's fairly short. It's fairly familiar. It looks a lot like HTML, for example, which a lot of people know. Now, the trouble with this is not all terminals have an escape code to selectively turn off just boldness. Some do, some don't, so we can't depend on it. And so in order to make this work, we'd have to hide state away somewhere, maybe on the string or in a parallel data structure. And that makes for both enormous code complexity in the library, as well as mental load and debugging for the user when inevitably something breaks. So what I ended up choosing as the best here was this attribute syntax. And the great thing about this, these attributes simply return the escape codes. The great thing is that it's consistent with, it works with, Python's built-in template formatting, this format method. And then to keep the nesting case, that red bold case short, we introduced this strange little thing, this mashed together method name, red bold. Now, admittedly, this is a bit novel, and I just told you not to be novel, not to come up with clever things. But I kept this example in the consistency section because it illustrates that all these principles are about trade-offs. We can't just turn all the knobs up to 11 all the time, or I wouldn't have to give this talk and all APIs would be wonderful. We'll talk about some of the benefits, the additional benefits of this mashed together syntax in a moment. So if you're going to do something a little weird like this, at least be self-consistent. This joined, mashed syntax is used for everything in blessings. Formatting, coloring, foreground color, background color, everything. It's impossible to get it wrong. You can put the different words in any order, and it just works. So the user doesn't have to keep referring back to the documentation to figure out what's valid. They just internalize one slightly odd idea, and that carries them through all of their use cases. Another great example of this, also with underscores, oddly enough, is Django's ORM syntax. It's got these double underscores everywhere, and this doesn't occur anywhere in the Python standard library. I mean, maybe before some method names, but not like this. But it's used consistently throughout the ORM. You apply it, you learn it once rather, and then you apply it everywhere. Now, when you're evaluating your consistency, there are some warning signs to look out for. Frequently referring to your own documentation, for example, or the source code you've already written as you're building your library. Thinking, what did I call that? Or what order were the document or the arguments in? A second one, if you feel like you're inventing novel syntax. So use your judgment here. What I usually think is make sure your novelty pays off rather than just shows off. Our third rule of thumb is brevity. This is a favorite of advanced programmers everywhere. Sometimes we overdo it. I like to make common things short, in tokens, sometimes even in terms of characters if it doesn't hurt readability. Here's our excerpt from earlier, and now you'll see why this mashed together naming makes such a good shortcut. So here's a very, very common use case. Setting some formatting, printing a string, and then returning to plain text. Since it's the most common, we make it the shortest. So this new line is equivalent to the line just above it. But not everything has to be brief, of course. If we're doing something a little more interesting or unusual, it can be a little bit longer. This is what you might do if you were trying to optimize the number of bytes going through the terminal. If you had a very slow modem or something. You set bold, you set red on top of it, and then you return to normal. Another way to think of this is when designing your API, your users should only have to pay for what they eat. Think of it like a restaurant. Ask yourself these questions about brevity. Do you find yourself copying chunks of code from your examples? That's no good. They're too long. Make it shorter. Do you find yourself typing something irrelevant, saying, oh boy, I wish I didn't have to say yes, one, or true. It should always be true. You should be able to assume it's true. Well, that's what a default smells like. That should be a default. A more subtle way that something that should be defaults can manifest is through long argument lists. When you're passing 7 arguments into each method, maybe those should be methods on a class, and you instantiate the class once and then call a bunch of methods on it. Making your abstractions composable. It means being able to reuse them in many different ways and plug them together in ways you haven't anticipated. Your users will show you things that you never intended. They're very creative. And there are a million ways to say this. Flexibility, loose coupling, small pieces loosely joined. But no matter what you call it, it all comes down to the minimization of assumptions. And there are 2 ways you can go about this, one of them wrong. Let's go back and see another way we could have done blessings. We could have chosen to hook printing and formatting together. Now, my friend Jeff Quast put together a really neat BBS system called x84. And it works over Telnet and uses blessings for its formatting functionality. It's got a multi-process design like Apache. There's a server process where all the formatting takes place. And then each connection to a client is handled in its own client process that hooked back to the server using a socket. Now, with this, there is no way to pass that output to the children because it's going out the terminal all the time. It's going out the terminal. You can't help it. Now, the wrong way to solve that would have been to add an option. And this is the tempting thing to do. Oh, I already coupled these together. Let me just add a flag, right? No. What's wrong with this? Well, it makes everything more complicated. We need to add a branch in our code to handle the option. We need to document the option. We need to write a test to exercise that branch in our code. So whenever I think about adding an option, first I look around for any other escape route. A better way, of course, is to break that coupling at the assumption point so that printing and formatting are separate. Now, because we followed the composability rule of thumb with blessings, Jeff was able to go ahead and stick formatted strings in memory and pass them between processes, even though he started x84 10 years before blessings existed. He's an old school BBS hacker. It was an easy retrofit because it didn't make many assumptions. So look out for these red flags about composability. Classes with a lot of state, a lot of instance variables, make me think that there are multiple little classes in there just struggling to get out. For example, I wrote a library called PyElasticSearch that talks to Elasticsearch from Python. And Elasticsearch is it's a document store, clustered document store. It likes to have lots of different machines hooked together, and then it figures out the clustering on its own. It's quite nice. That's the elastic part. Now, because of the clustering, one feature we needed was a penalty box. We needed to notice that this node I'm trying to talk to is not responding, and think to ourselves, well, I'm not talking to that node for another 5 minutes. I'll go over here and talk to this node. Now, at first, I was tempted to add that, in fact, I did add that, directly to this Elasticsearch connection object, along with all of the other things that it was responsible for. And then I started to smell a lot of instance variables in there. And so I thought, well, let's break this off as a separate class. And here's our decoupled, composable penalty box. Now, here are some cool ways this can be reused. The penalty box makes very few assumptions. It doesn't know about networks. It doesn't know about URLs. It doesn't know anything about Elasticsearch. All it has is arbitrary things you can fill it with. You can ask for a random thing, and you can tell it, hey, this thing isn't responding. Punish it. Put it in a penalty. And as a result, we can reuse this any place. We need a penalty box. We can use it in games. We can do whatever we like. A second warning sign is deep inheritance hierarchies. Now, people say composition is better than inheritance, and here's why. If you inherit, that's the easiest thing to do, right? You get ready access to all the methods and data of your superclasses. But the trouble is, you get a lot of responsibility with that capability. You inherit all of the invariant baggage of your superclasses, all that responsibility to tiptoe around its instance variables and not make them invalid in combination. You have to not make them invalid, but the language doesn't help. The language says, sure, you can write to those private variables. You can do whatever you like. It's Python. We're all friends here. So subclassing just increases the amount of code that has to tiptoe around that state. Instead, it's often better to instantiate that would-be superclass and put it inside your object as a variable. Now, subclassing ran amok in Zope 2. I used to do a lot of Zope 2 work. And we had inheritance hierarchies 20 or 30 classes deep and multiple inheritance. We had to build this tooling called DocFinder tab just so that we could guess where a method might be defined, maybe. And then, in case that wasn't enough fun, we had invented a whole sideways kind of inheritance that was dynamic and could only be figured out at runtime. So, yeah, don't make the Zope 2 mistake. There's a reason everyone runs out of the room whenever someone says Zope, and I thank you for staying. Then we have the law of Demeter. Now, this is cool. This works in every language. And basically it says, if you do compose, no cheating. Now, if the Elasticsearch object contains a penalty box object, then the outer object can feel free, of course, to call methods on that inner object. You can call methods on the penalty box. Here's a node, get me a node, punish this node. But you're not allowed to drill farther in. We're not allowed to say, oh, let me see what's in that penalty box. Let me grab one of those URLs from there and let me uppercase it and stick it in a database. No, don't do that. We have to maintain abstraction. If we don't maintain abstraction, then there was no point in separating those objects to begin with. Mocking. Who uses mocking in tests? I have to do that sometimes too. But every time I feel really bad about it. You should feel bad too. I find that if I'm mocking out too many dependencies in my code usually has too many dependencies, makes too many assumptions. For example, how would you test this? Well, since it's all coupled and assumes it's going out standard out, you'd have to go into the sys module and mock out standard out, and then maybe put a string IO object in there. There's another library you need string IO. And then you have to pull the value off of string IO, and then you need to remember to put sys back how you found it, because otherwise, who knows what's going to happen. So you probably need a mocking library to help you remember to put things back how you found them, even if the test crashes. It just makes for a lot of code. This, on the other hand, doesn't need any mocking. It's straightforward. You just call format and say, yeah, assert this equals that, and you walk away and you're done. Testable code is decoupled code. And then, of course, look out for profusions of options. Now, another rule of thumb that helps with reusability is plain data types. Whenever possible, express your API, its inputs, its outputs, as native to the language data types. In Python, strings, integers, dictionaries, all good. Not big custom classes that you have to construct and pass into your methods, and then you get them back, and you have to look up documentation to see how to get stuff back out of them. Because it's likely that the rest of your program is not written in terms of those custom objects, right? You're going to have to convert back to native data types anyway. So you might as well save the step. The aim should be to reduce barriers to reuse. And here's an example of a barrier. This is the config parser class out of the standard library. And its purpose is to read INI files. Who's used config parser? So I've used it as well. And unfortunately, it is not just a parser. It doesn't just read the file and give you back something simple like maybe a nested dictionary, for example. Instead, it sticks around forever and returns this big config parser object, which you then have to express the entire rest of your program in terms of. Now, the trouble with this is the config parser object does not conform to any Python language idiom. This means that any code that calls config parser has to be written in terms of its weird method calls. So you're stuck with config parser forever unless you want to rewrite your program. If you wanted later, for example, to have the flexibility to read maybe YAML files or some other kind of configuration, maybe pull configuration out of a database, you'd have to put a facade around this, or replace it and rewrite, or wrap it with something. Extra code, extra trouble. Now, I'm going to continue picking on config parser, and I'll pretend that it has a slightly worse API than it does, just for the sake of argument. Let's pretend that there's a read method, which there is, and let's pretend it takes a single file name, which it does not. Now, this might feel like a convenience, because, of course, it's very common to read configuration out of a file. But if that's the only way of getting configuration in, then that is a barrier to reuse. A method should take what it needs, the minimum thing it needs, and nothing more. We need, in this case, a string. The configuration is always a string. We don't need a file. It's not 500 megabytes of configuration that we need to seek around in or load incrementally. It's probably a 10 to 20K config file, and memory is big. So, I would introduce a parse method that takes a string, and that would be the core method. And then if we want, we can also add a convenience method that wraps it. Something like, well, we could give a file contents function, a utility function that turns a file name into a string, or we could also have this read method that it comes with. but we also need parse. Imagine trying to write a test that has to set up some configuration first. We don't want to be writing out temp files in our test and then reading them in and remembering to delete them. That's a lot of extra code. Fewer assumptions makes everybody happy. Now, even when you have a more inherently complicated data structure, expose as much as possible using built-in or native data types. One of my terrible libraries is called SpiderFlunky. And it is, I suppose, a client of SpiderMonkey, which is Mozilla's JavaScript engine. It uses SpiderMonkey to parse some JavaScript. And then SpiderFlunky knows how to walk around the abstract syntax tree and return interesting information, find the function calls and variables and such. Now, to walk this abstract syntax tree, I needed a doubly linked tree, excuse me. Now, there aren't any of those in Python. We could have nested lists, but that only links in the one direction. I needed to be able to climb back up the tree. So I had to make a class, and I felt bad about it. But there you go. However, I got back to native data types as soon as possible by, well, in this case, adding a walk-up method. We are transforming here the doubly linked tree back into a native Python thing, the iterator. So I can say something like, for example, well, let's take a look here. I can find the nearest scope in JavaScript by walking up from any line, or any node. Just with a nice little generator expression, I can say, hey, for n in walk up the tree, take the first one that looks like a function declaration or is just the global scope of the program. So if you can't have plain data everywhere, at least return to it as soon as possible. Plain data warning signs. If your users are immediately transforming your routine's output into something else, just return the something else. If you are doing the reverse, if you are requiring them to make some big object and then pass it to your routine, why not just take the components if you don't expect that they'll be reusing that bundle of attributes? And then, of course, if you find yourself re-expressing, respelling things that the language already provides in different terms, like config parser with its get section option, I mean, that would just be dictionary, square brackets, one key, square brackets, another key, right? That's already built in. Why change it? Now, grooviness. Let's see how this translates. In English, there is this idiom of being in the groove. Like if I were running a marathon and, the first mile, it hurts. You're not really warmed up. It's uncomfortable. But then miles 2, 3, 4, you start to settle into the groove and you're feeling okay, Things are heating up and you're loosening up before you get tired at the very end. And I have this same idea in my APIs, that users should spend most of their time in the groove, in this period of ease. And you can even bring more physical metaphor into it. Think of programming as walking across a plane. And I'm kind of walking in this worn path, this groove here. I could close my eyes, and if I walked over to the right, I could feel that the groove was sloping up, and it would tend to push me back down into the groove, where I'm more comfortable. Now, of course, there's nothing keeping me from stepping out of the groove if I needed to. That would be fine, and then I could step back in when I was finished. But the groove is attractive, and new users are drawn there without really needing to be dragged. Let me give you a few ideas on how to cut grooves in your APIs. First, avoid nonsense. Let's talk about PyElasticSearch again. Now, there are two different ways to query Elasticsearch. You can use this big, powerful JSON that's long, or this little simple string that's short but not as powerful. There's no such thing as a query that uses both. You have to choose exactly one. But this is what the old PyElasticSearch search routine used to look like. Notice that all of the args are optional. So you'd pass in string-style queries using the QArg, and JSON-style queries using the body arg. I don't know why. Of course, that meant nothing stopped you from doing this or even this, both of which are complete nonsense. Certainly, you shouldn't need code in your library to check for this sort of silliness. We should be able to make the language fail. Now, the new Elasticsearch replaces that mess with a single routine that takes a single argument. Query. If you pass a dictionary in, we say, oh, that's JSON. If you pass a string in, well, it's obviously a string. You can't mess it up, and it's much groovier. Now, incidentally, this turns up another principle, which is to fail shallowly. In our case, the interpreter would give us I believe a type error, a type error if you have the wrong number of arguments. Failing shallowly is something that's, nice in a language that gives you tracebacks. But if you're using a language like JavaScript that might not give you very informative tracebacks, it's vital. So in JavaScript, I can't tell you how many times I've spent a weekend just crawling through the debugger trying to figure out how an undefined or a nan got into some object attribute. Where did this thing come from? I wish I had just crashed with a key error when I, accessed this non-existent key or did this weird math thing. I actually got to talk to Brendan Eich, the inventor of JavaScript, and he told me why it was like that. I mean, JavaScript was never really intended to be used for large projects. They figured, we'll use it for a little animation or something, or to scroll a marquee in the toolbar. And it was just designed to keep on going no matter what went wrong, right? Because whoever's looking at the web page is probably not a developer. There was no such thing as JavaScript development tools then. There was just alert. And so JavaScript was just designed to keep on going no matter what went wrong. That's why that decision was made. And now, of course, we're stuck with it. That's legacy for you. So don't make that mistake in your APIs. Another way to provide grooves is RAII. Here is a poppable balloon class. But as you can see, when you first make one in init there, it has no air in it. So if you tried to pop it, it would just go squish, maybe. Now, you could imagine writing some documentation that says, hey, before you pop the balloon, make sure you fill it with air. But that's kind of a design smell. When you start writing documentation, especially along the lines of, make sure you do this, makes me think maybe I need to go back and improve my design so that you can't screw it up. A better way would be to take the initial fill amount on construction. Take, 10 cubic centimeters of air at STP, for example. The user is required to provide it. They get a prompt error message, a type error. If they don't, and, if they want a balloon with no error, they have to pass 0 explicitly. So there's no wondering why I pricked the balloon and nothing happened. So RAII is just a case of don't have invariants that aren't. Now, a final way of providing grooves is through compelling examples. And these are the most overt sorts of grooves, but I think also the most enjoyable. Now, this screenshot is from MacPaint 1.0. Who's used MacPaint 1.0? I'm the oldest person in the room. That's official. But I bet you recognize this layout. The palette on the left of tools and menus on the top, and menu items in a title bar. There's a title bar there. I mean, this looks familiar to everyone in the room because Illustrator and Photoshop and Paint Shop Pro and the GIMP and Pixelmator have all been copying slavishly for the last 30 years. Another example, Nintendo side-scrollers, right? This is 30 years ago now, 40 years ago, a long time ago. But even today, we are still jumping and running to the right and defeating enemies and collecting goodies. If you set a good example, people will follow it happily forever. Now, I used to write example code for my libraries in a very pedagogical fashion. Long names, big comments everywhere explaining everything, inefficiencies for the sake of clarity. And I ended up being forced to stop doing that because people were actually copying and pasting the code right out of my examples, sticking it in their production systems and wondering why is this performing so slowly? They would even copy my comments and stick them in there, even if the comments were completely out of context then. So don't underestimate the docility of your users. They will happily do whatever you recommend. So, recommend suitable things. Maybe take those comments and pull them out of the code into prose around your code excerpt. So with grooviness, look out for nonsense states. Look out for invariants that aren't really invariant. And then watch users if you can. Watch someone at a sprint get started with your library, and don't prompt them too much. See if they know where to start without referring too much to documentation. The tech writers in the early Macintosh project played a large role in making sure users could discover organically how to use software. They would come back to the programmers and they would say, so I'm like 5 pages into describing this feature now, and that's a lot of paper. Maybe we should make this feature easier to use. And they would tear it all down and they would start again. So if your API is hard to explain, maybe it's too complicated. Go back, see if you can simplify the design. Incidentally, this is why I like README-driven development. I tend to write the README first, full of examples of call sites, and then all I have to do is make that work. Now we get to the walls. So walls are to keep you from hurting yourself or others. Just as in the physical world, there's a continuum between grooves and walls, a bit of a slope. The more damage you can do with a feature, the higher the wall should be in front of it, the meaner the barking dogs, the more razor wire. Here is a horrible API with not enough walls. And who sees what's wrong with this? Yeah, maybe it's bitten you in the past like it has me. Who here has wiped out a whole database column because they forgot the where clause? I've done it. Yeah. One way to fix this in the design might be to require you to say all if you mean all. Maybe it's less mathematically beautiful, but most of us aren't mathematicians, and beauty aside, imagine all the hours and pulled hair it would have saved since the beginning of SQL. I mean, that one little word, right? Save a whole industry. Here's another old chestnut. This is good. This is a pretty common thing to do in Python 2, anyway, Python 2. But the trouble is, to do this, first you have to type this. Yeah, it's seriously bad news. Now, don't hit return too early. Now, fortunately, a lot of shells, my shell included, I just tested this the other day, have put up a wall in front of this. If I enter this, it'll say, hey, you need to say -F if you want that to work. Very nice wall. I'm sure it saved a lot of trip stacked backups. A similar sort of thing, actually the exact same thing, we never learn, happened in Elasticsearch. This is what the delete method used to look like. It deletes a document based on its ID. Document is like a database row. Now the thing is, the Elasticsearch delete method, the REST API, if you don't pass it an ID, it'll happily delete all your documents. Isn't that great? It's very convenient. And here, ID is optional. So how can we fix that? I mean, I can certainly imagine leaving it out by accident, or I think I've typed the ID, but I've omitted the doc type, and it's just terrible. So here's how we fixed it. Now ID is, pardon me, mandatory. And then we added a second method called delete all for those weird cases where you actually want to delete all the documents. You can't possibly screw this up by accident. You can only now screw it up on purpose. And then the other thing to consider about walls is how to report errors. In Python, like in so many languages, you have two main choices. You can return something, or you can throw an exception. And raising an exception is almost always the better choice here, since it reduces the possibility of accidentally ignoring an error. So watch out for documents that say remember to, or make sure you, or especially like make sure you do this first, or make sure you do this afterwards. That smell is that's the smell of a context manager you detect. That's a wonderful thing about Python. You can say, hey, with opening the file, and then it'll close the file afterwards. Second, ask yourself what the most damage you can do with your library is, and then make sure that there are nice walls. You can't do those by accident. Now, there's a cultural thing here. You need to make sure that, be aware that your users are not going to report things that they perceive to be their fault. I made a mistake, and I deleted my entire database. That's the sort of thing that manifests in documentation as, make sure you put on that asbestos mitt before you grab the red hot doorknob, No. That's a design mistake. That's not user error. Why do you have a red hot doorknob in your design? No. Take that away and actively watch out for your users' well-being. So here are the 7 principles, all summarized. And I like to keep this checklist out on the desk when I'm designing an API. When I think it's pretty good, I look through here and see if I'm making any obvious mistakes. But let me get meta for a second. You may have noticed that there were no big black lines between these principles. Some of them just kind of flow into others. Using plain data, it helps with composability. Brevity is an aid to grooviness because it makes it easier to remember things. So I started to wonder, does any order arise out of the relationship between these principles? And it turns out that it does. If you lay all these out, and then you connect them with arrows that mean this contributes to that, they divide almost perfectly into these 2 clusters. Now, the left cluster seems to be human things that are qualitative, compactness and grooviness, things that are for human comprehension. And the things on the right maybe are more calculable, things that might have an absolute impact on the number of lines of code in the system, not taking human comprehension into account. So if you like, the left is lingual, to put a nice symbol on it, and the right is mathematical. Now this was a pleasant surprise to me because when I was a senior in high school, I was told that, hey, programming is, basically math. And that made me sad because I had already done some programming and I had never done anything more complicated than multiplication in it. Didn't seem to need any particularly difficult math to get things done. And so I really didn't believe it. And even today, I'm more of a lingual thinker than a mathematical thinker. But we can see how the 2 meet in the middle and that both are necessary to make a program that actually is functional and comprehensible. The math language duality also highlights the thing that programming languages have over and above ordinary languages. Programs are alive. They not only mean things to people when they're read, but they actually do things when they're run. So in a very literal sense, a program with carefully chosen symbols is poetry in motion. Muchas gracias. I want to thank my good friend Ricky Rosario for translating my little quotes. I hope you're watching, Ricky. Thank you, Melina. Thank you for translating for everyone so that I could not have to learn Spanish in a month. That was wonderful. Yes. And thank you all for coming. ¿Preguntas? Very good. I can hear you. Talk loud. See. I will make it a PDF, or better. I will make it text so that you can mix it. I'm sorry, I will repeat the question. the checklist. Will it be available online? Yes. I will tweet it out. I'm Erik Rose on Twitter. So let me ask you a question about your library, and the question I should repeat was, and let me know if I got this wrong. You have a library to extract from your program, but it still seems too complicated to use without a lot of documentation. Is your problem inherently complex? Is it your static analysis thing, for example, we were talking about last night? Caching. Well, maybe we can sit down and take a look at it. What I try to do with documentation, and I always do end up writing documentation, I'm not saying you should never have documentation, is give an overview of the concepts that you will need to understand this library. For example, with blessings, I'll say things like, there are these terminal escape codes, in case you weren't familiar with them. Now here's how you get them out of blessings. Oh, boy. There are a lot of good APIs out there. I think probably my favorite API would be the Python iterator API. It is so pervasive, and because of its pervasiveness, so useful. You could iterate over lists, over dictionaries, over dictionary keys or values. You can iterate over, sets. Everything is iterable in Python, just like everything is a hash table in Python. And because of that common interface, you can mix any two things together in Python. You can for loop around anything. You can while loop around anything. You can even go into the functools library and pull out, the context manager decorator and context manage around an iterator. And we can see what a good idea it is because JavaScript is, stealing that. Yes. What do I think about static typing and the information it provides at the level of API design? It's interesting that you asked that now because I have had my thinking evolve on that point over the last few months. I dislike typing. I dislike typing, not typing. And so I've always liked my languages to either be dynamic or to infer types. I still like type inference. I think Swift, if you've seen the Swift language, I think it makes a good trade-off. It does type inference, but it either forces or encourages you to specify types at the method signature level. I've noticed that in Python, which has no, annotated types, I end up writing the type information into the doc string anyway. And then it's not in a standard way, right? And maybe you document your program in Espanol and I have it harder for me to read. Yeah, so I actually think that the types are useful at the level of function declarations. They give you something to go on. Now, of course, you'd want as rich a type as possible. String is not the best type for a URL. It would be nice to have a type that's URL. That's what I think about static types. Audrey. A very good question. What do I do with my great ideas on how to fix my old APIs to be better when they're already in use? So you have two big choices here. One is we never run out of integers. You can always release a 2.0 and say, all right, everybody, change your stuff. Here's 2.0. Everything is different now. I tend to use semantic versioning. Even in more iter tools, which is an iterator library of mine, I changed one routine signature from a tuple to a list, and I bumped the whole major version for that. Better to be safe than sorry. The other way is, this is where I can be prevailed upon to introduce options to things. I think this is a good use for options. As if it's just a simple behavior switch, for example. And of course, you'll have to write a test for that and documentation and everything. But if it improves life for your users, great. The other thing you can do is break things into smaller composable units. So I can go back to Elasticsearch. We had, there's this bulk loading API in Elasticsearch for grouping lots of inserts or other operations together in one HTTP request and sending them all at once. I had this huge routine for, being able to specify, here's a get, here's a put, here's a get, here's a put, here's another get, and another get. And it became a very complicated routine. Maybe that, with so much complexity, would be a good place to actually go ahead and create smaller intermediate things which you pass in. And then you have other external routines that create those smaller intermediate things. And then you can replace those little intermediate routines and deprecate old ones. You may not have that pattern, but it's an idea. Four-dimensionality is not a solved problem in software. The future is hard to predict. There was one over here. Yes? Oh boy. A fun question. What do I do at Mozilla? How do I get to apply all of this stuff? I work on a static analysis and search package. I guess it's going to be a Python package soon, called DXR. I'm not going to try to work the conference internet. It's never a good idea. But DXR is a tool for making sense out of large code bases like Firefox. 16 million lines of code, and because of DXR, we can do a regular expression search on all that code in 80 milliseconds. It also does a little bit of static analysis, like, where is the function defined, who calls this function, who uses this type, if I change this function, who will become angry at me, that sort of thing. And the API design, well, it's not just for libraries. In fact, it's even more fun if you're not writing libraries, because then you won't disappoint people who are calling in from the outside. Every time I make a function, I'm defining an API. And every time I name a variable, I'm defining a memorable word that hopefully describes what's in the variable. So you never stop designing APIs. You can't escape it. Sure, yes. We do a lot of code review at Mozilla. Most of our projects work on what I call the buddy system. We may have a team of 5 people. If I want to put some code in, I open a pull request, and then anybody else can sign off on it. And then it goes in. And very rarely do they not find some mistake in my code. It's very rare. Más preguntas? All right. Thank you very much.